Okay, these are the 5-2 notes. Yesterday we talked about using the addition and subtraction properties of inequalities to solve inequalities. And basically what those said is I can add or subtract the same number to both sides of an inequality and that inequality remains true. So the same thing is going to apply for multiplication and division. There is one thing, however, that changes a little bit with multiplication and division. Do you remember from the 5-1 notes, I said that we want to keep things positive because if they turn into something negative, things change. We'll get to that on the next page and I'll show you what I mean. So, basically we're going to start with the multiplication property. And it says if you multiply both sides of an inequality by the same positive number, this is really important. If you multiply by the same positive number, it stays true. So if I have 4 is greater than 2, that's a true statement, and I'm going to multiply each side by positive 3. I get 12 is greater than 6. Still true. All right, so if I have an algebra example, I have 2x is greater than or equal to 12. This one's not going to be solved yet because that would require division and we haven't gotten that far just yet. We're just going to multiply it by the same number and say, even though it still has a variable in it, it's still a true statement. So I'm going to multiply both sides by a positive 4. If I get 2x times 4, I end up with 8x on the left, greater than or equal to 48. Now, that's great. We can't do anything with that because we don't know how to solve it just yet. We haven't covered the division yet, but that's an example of where just because you multiplied it by a positive number, you still keep the inequality symbol the same. Turn to the next page. Now, this is where things start to change. It tells us that if you multiply both sides of an inequality by the same negative number, you must change the inequality sign. And when they say change it, they just mean flip it over. And then it will still be true. So if I have 7 is greater than or is less than 9, that's a true statement. Let's just multiply it by negative 1 and see what happens. I end up with negative 7 and negative 9. Now if I were to leave the inequality symbol the same, I would say that negative 7 is less than negative 9. That's not true. So that's why we have to flip the sign. All I do is instead of less than, I make it greater than. So it's just kind of hard to remember. That's something you're going to have to make a note of every time you see something negative or positive. Remind yourself if I'm multiplying or dividing by negative or positive or a negative, I have to flip the sign. Okay, here's an example just like before. We haven't learned anything about division just yet, so we're just going to multiply it like we did on the second one on the first page. Let's go with, let's say, times negative 2. So over here becomes negative 12x. On the right-hand side, I get negative 36. Now this is greater than or equal to, so I have to flip the sign to become less than or equal to. All right, turn to the next page. You can solve inequalities by using the multiplication property of inequality, just like from section 5.1. We have 1/8 times n is less than 84. Now remember, if I take 1/8 times n, it's the same thing as n over 8. It's less than 84. This line means division. So to undo that division and thus solve our inequality, I'm going to multiply both sides by a positive 8. And I get n is less than, let's see, 84. 672. Our inequality symbol stays the same because it was a positive number. Next page. You can also use multiplicative inverses with multiplication properties of inequalities. Now don't get caught up with multiplicative inverse being a big word. Remember that inverses are just fractions flipped. So when we come down here and we see negative 3/7 and I want to get rid of it, I simply multiply by its inverse and it will give me 1. So to solve this inequality, I'm going to take each side times negative 7/3. Negative 7/3 is just the inverse of negative 3/7. These are going to cancel. I get r, and now this is a negative number and I'm multiplying, so I have to flip the symbol to greater than. And let's go over here and do our multiplication. I have 21, which is the same thing as 21 over 1, times negative 7/3. The 3's cancel, or the 3 and the 21 will cancel, and this will become a 7, and this will become a 1. So I get negative 49. That's my answer. Okay, here's another example. I have 3/8, t is less than 5. To undo multiplying by 3/8, I have to divide by 3/8. But division by a fraction is the same thing as multiplication by its inverse. So I'm going to multiply both sides by 8/3. These will cancel and become 1. I get t. Now I'm multiplied by a positive number, so the inequality symbol stays the same. And I have 5/1 times 8/3. Nothing can cancel out here, so I just get 40/3. And I'm going to leave it in that form. All right, next page. Division property of inequality is the same as multiplication. If I divide by a positive number, symbol stays the same. If I divide by a negative number, symbol has to be flipped. So let's start with the positive numbers. If I divide by a positive 2, or let's go with a positive 5, I get negative 2 is less than negative 1. That's a true statement. All right, how about down below? We'll divide by a positive 2, and I get 3x is greater than or equal to 6. Okay? Now, something I could have done is, since we're learning about the division property, maybe I want to solve this. So I'm going to divide by 6, because right now it's saying 6 times x. So to get x alone, I should undo that multiplication by 6 by dividing by 6 on both sides. And I get x is greater than or equal to 2. All right, next page. This is where it starts talking about dividing by a negative number, where we talked before, if we divide both sides by the same negative number, we have to flip the sign in order for the inequality to stay true. Let's go down here. If I divide each side by negative 3, I get negative 5 and negative 6. If I were to leave the symbol the same, I would get negative 5 is less than negative 6. That is not true, so we have to flip the sign. All right, so down below, I want to divide. I'm going to actually make this a negative 8 first, and then it'll make better sense. So in order to solve this, I have to undo the multiplication by negative 8 by dividing by a negative 8. I get x is less than or equal to, I had to flip the sign, positive 3, and that would be my solution. All right, turn the page. So we can use division just like you can use addition, subtraction, and multiplication to solve inequalities. If I have 60t is greater than 8, in order to solve for t, I divide by 60. I get t is greater than 8/60. I want you to leave it in fraction form, but we can reduce it. So I'm going to reduce it by 4, and that gives me 2/15. And that would be my solution. The next example says negative 7d is less than or equal to 147. To undo that multiplication, divide by negative 7 on both sides. I get a positive d, but remember I have to flip my sign because it was a negative 7, and I get negative 21. That would be my solution there. All right, turn to the very last page. This is a word problem that we set up. It's going to be very similar to the ones you'll see on your homework, but we'll do some more practice tomorrow in class. The word problem reads, the Cullum High School Band raised more than $5,500 from fruit sales. Fruit was $15 per box. Define a variable and write an inequality to represent the number of fruit boxes that they sold. Solve the inequality and interpret your solution. The very first thing we're going to do is define a variable. Now, we know they're raising money by selling boxes of fruit. What they want to know is how many boxes did they have to sell to make at least $5,500. So I'm going to define it as B is the number of boxes that they sold. Okay? Now I know to find out how much money I make, I have to take $15 times the number of boxes that I'm going to sell, and that's going to give me how much money I make. We know that they want to sell $5,500 or more in fruit sales. So this number has to be bigger than $5,500. It's more than. It doesn't say anything about equal to. Okay, so we put our $5,500 on the right-hand side. Now to solve, I simply have to divide on each side by 15. What do we get here? What does that give me? It should give me I get 366.67. So they have to sell at least 367 boxes. Remember, they cannot sell 2/3 of a box. Okay? Now, the last thing it says is to interpret your solution. The band must sell at least, or no, sell more than 367 boxes of fruit to make more than $5,500. Okay, so let's make sure we did everything. Define a variable. Yep. Write an inequality. Yep. Solve the inequality. Yep. And then interpret your solution. Okay. That is the end of the notes. You need to take a look at your homework. Make sure that you complete the assignment from 5-1. We will go over some examples tomorrow in class, and I will see you tomorrow.